So let's start. Okay. Hello, everybody. Labvakar. This is the only word I know. Okay, so my name is Vladimir. Today we're talking about forgetting Java and moving to Kotlin coroutines. I'm super excited of being here and seeing you all here. Cool that you have interested in that topic. Several questions from my side. Who knows what Kotlin stands for, except for the programming language? Yeah, it's an island near St. Petersburg. It's basically the city I was born in and where I currently live. Hope that will be changed soon, but let's not to predict the future. Short disclaimer, everything I'm talking about here is a product of a production experience and research activities. So there could be some mistakes or inaccuracies. Please forgive me for that. Okay, so who am I? My name is Vladimir Ivanov. I'm lead software engineer in PEM systems. I published a lot of apps. I'm doing that for more than 7 years, and Android is basically my primary skill. But I'm doing a lot of other things. I'm doing iOS development, so development with React Native, doing some solution architecture. Right now, I have a position of a mobile solution architect for several internal PEM projects, and I'm a certified Google Cloud architect. So if you want, we could discuss the Google capabilities in that field. So we obtained some fancy stuff for completing the certification. Okay, so who are you? Are there any Android developers? Or everybody are? Just raise your hand. Don't be shy. Raise your hand. Okay, half of us. Okay, .NET developers. One. Enterprise Java developers. Okay, a lot of you. Cool. You should be interested in the topic. Okay. What about JavaScript? Why not? Why don't you write JavaScript? It's rather fancy. Well, basically, React Native uses JavaScript for mobile development. So .NET developers, JavaScript developers should know that async await thing, right? Who knows it? Okay, several of you know. What you can do with async await, you can code some asynchronous work in a way that it seems like synchronous. Okay, so this is a code for JavaScript. Imagine you need to code some application that needs to authenticate against GitHub, right? So what you need login and password, and you're making some authentication string and just put it to GitHub service. And here you can see that you're using async and await keywords in JavaScript. And the rest of all the code is written like there is no asynchronous work, right? So we just think that this network call just happens here synchronously, and that's it. And we handle the response, handle errors. And this is very easy to read and very easy to write and easy to maintain. So indeed, it is easy. What if I told you that Kotlin can do the same? Sounds good to me. I don't know, but I will try to convince you that in Kotlin you will be able to do pretty much the same, and is the way that you write your asynchronous code. Okay, so let's check out what we do now with RxJava. Imagine we're writing an application, maybe Android one, maybe a desktop one, maybe a web one, and it should authorize with login and password against GitHub, right? Get the list of repositories for the particular user, and maybe provide an opportunity to search for some repositories in the GitHub. Okay, so on Android it will look like this. So all the code that you see here is actually on my GitHub. I will provide a link later. And it looks like this. So the app just has a couple of inputs for login and password and the button, let's sign in. And after we sign in, we see a list of our repositories and maybe a search field that provide the capability to search for other repositories. Okay, so I conducted a poll in my Twitter and with a question, if you're doing a new Android project or maybe other one, what you're going to use for your asynchronous work. And a lot of people, like 65%, picks RxJava. And I believe that RxJava is not a tool to make asynchronous work. It is a library for process event streams, right? And not just asynchronous thing. And coroutines fit that purpose much, much better. And this talk is actually about why. So for the application I mentioned before, the RxJava 2 implementation will look like this. So imagine we have an interface like API client, and we have a couple of methods like login and get repositories, and each one returns some single thing for our business object. So for login thing, it is a GitHub user object, right? And we return single thing. For get repositories, it's a list of GitHub repositories and the single for that list. Any questions right now? OK. So yeah, just a bunch of singles. The implementation is rather easy. We do some HTTP requests, then analyze what is the status code. And if everything is good, then we just obtain the JSON object, convert it to GitHub user, and go with it. And the only thing that RxJava brings here is that we need to call single from callable in order to use it properly, right? OK. Get repositories method is pretty much the same, just another call. And here you can see two repos method. It's just extension method for a list that I just written myself. OK, what about the client code that uses the implementation of that interface? It's pretty complex, right? Let's go step by step. First of all, after we first call with login, we need to use the flat map operator and convert the obtained user to some other request that will go and obtain the repositories, right? Using the object and some URL from that object. Then we need to map the list of GitHub repositories to the list of strings, because on the display, on the screen, we don't need objects, we need strings, right? Then we need to provide some schedulers for the chain to know on which threads to perform their network requests, on which threads to perform the subscription logics, and that's it. And finally, we need to subscribe and provide some logic to perform the displaying of the list that we obtained. OK, any questions right now? OK, everything is clear. Great. What about the caveats in that code? Do you have any ideas? Sorry? Debugging. Yeah, debugging is hard. Anything else? I came up with the following list for that code. So first of all, RxJava creates a lot of objects under the hood, and I'm going to show you that. The stack traces that you're going to get in case of some problems will be unrelated completely to your code. And the learning curve for RxJava, for new developers, for new persons on your project, will be rather steepy. So it will take a lot of time to get to know RxJava well. So OK, let's go just for the bullet list. First of all, a lot of objects, right? So this is a memory footprint of the chain above. And you see that we have like 19 objects for a couple of requests. I think that's a lot. And the reason for that is that for each operation that you invoke on that chain, RxJava under the hood creates a special object to handle that logic. So the more operations you have, the more operators you use, the more will be the memory footprint. OK, what about the stack traces? The stack trace, don't try to read it, because it's completely unrelated. The only line that relates to your own code that you've written is here. API client Rx, blah, 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 blah. But the problem is that it is the last point that your code was invoked. So this is not an entry point to your use case. So if you get that stack trace in your Fabric or other Crashlytics tool that you use, you won't be able to understand which use case caused the problem. Thus, happy debugging. OK. What's this? Okay, what if I told you that coroutines can do that much better? Sounds good, right? So let's talk about coroutines. First of all, they appeared in Kotlin 1.1, and they are stable from Kotlin 1.3. It's like 2 months already. The implementation, the naive implementation with coroutines for the same code will be the following. So we have the same API client interface, and what we changed was we transferred from singles to some objects that called deferred. Just the objects from coroutines world. Okay, not a big deal. But the client code changed drastically. So first of all, that we have some launch call. Then we see some logic, but basically the structure of this code is completely changed, because you don't have some chain or some operators or other things. You just write the code you want to execute in the mean that they're synchronous, like there are no asynchronous work. For example, you just call the first method of your interface, then you call another method, and that's it. And all you need is to provide the code that will handle the response and handle the errors. But we will get back to that a little bit later. So advantages of that code are that it's much easier to read than with the RxJava case. It is written as sync. However, there is a lot of async work there. And error handling is like for sync code, like with the means of the language, with try, catch, finally, and not with operators like do finally and whatever. So what about RxJava disadvantages? First of all, the number of objects that are created under the hood. They are much less. So we have just 11 objects, so it's 1.5 times less. That's good. What about the stack trace? Well, actually, the stack trace will be unrelated as well. So only the first line is related to your code. But the good news is that just 2 weeks ago, like 14 days, the team of JetBrains provided a debug library that helps you to understand what your stack traces stand for with a special library, and the link is here. I believe Alexei will share the slides, so you will have the access. So debug enables capturing the original coroutine stack trace, so you see what use case caused the error, and that's great. And here's the example, so you can see that. I'm not sure you can see it, but here there are links to original source of the operation that created the coroutine. That's good. The direct style that I already mentioned. So, for example, you need to process some UI, right? Because you need to show a progress, and that's really easy with coroutines because you can just call show progress here. Then, on the same level of indentation, just call the show repositories, and if something goes wrong, just show some error message. And finally, just switch off the progress once the process is over. Okay, cool. Error handling. And one more thing that is better than RxJava, that if you need some custom logic, for example, a for loop, it's way easier to provide with Kotlin coroutines, because in RxJava you need to write your own operator, handle a lot of corner cases, and that's it. With coroutines, it's better because you just use the standard operations. For example, a repeat function. Just put it in your code and it will work. So that's awesome. What about the async function implementation that we were using? Well, the body of the function didn't change much, so it is basically the same. The only thing that changed that we're not returning a single, but we're returning something called deferred, and we use a function that is called async, and that's it. So this is all your refactoring. You just replace the RxJava objects with coroutine objects, and you're done. It works. However, there's some caveat. With structured concurrency that was introduced in stable version of Kotlin coroutines, you will need a thing that is called Corrosion Context, but we will get back to that a little bit later, a couple of slides later. But first of all, let's figure out what async stands for. So async is a coroutine builder. Does anybody know any coroutine builders here? Anybody? No. OK. So first one is launch. It just basically launch some async code and don't return any answer. Then we have async. It returns a deferred. We will take a look. A run blocking, which is very useful in tests, and with context. OK. So the launch thing returns a job. Basically, the job here is your coroutine. And the interface of that job is here. So we have a bunch of fields like is active, is completed, is cancelled. It will be useful for us a little bit later. And we have some method like start and cancel. And that's it. Pretty easy concept, right? So the async coroutine builder returns a deferred. And deferred is an interface that extends job and adds a function that is called await. And if you pay attention, you can see that this await returns your type that you want to receive from that asynchronous operation. OK, so this is the way coroutines return the value from your async functions. OK, conceptually, deferred is a future, like future again. But the difference is that deferred is a non-blocking. So when you call future get, your thread is stopped. It is paused in that moment. But for deferred, it is not true. It gets suspended. And of course, deferred is cancelable. So for any other types, for any other futures that you can encounter in your Java libraries, for example, completable futures or other futures, there are already the extension functions that are called the same, await. And if you use Google Guava, for example, you can use those extension functions that are shipped with coroutines library. And that's good. So await is like future get, but non-blocking, as I already told. And it uses suspension. Let's figure out what is suspension. What do you think I will get in a Google search for images if I put suspension there in the search field? Yeah, yeah, that's one. But this is this is not the picture that we're looking for. Actually, the suspension happens in the following way. So for blocking world, for futures, for gets, for otherwise, what we have is that we have a thread and some function is calling for future get, for example, and the thread is blocked, so it doesn't have any computation time anymore, and this is actually bad. The suspension is that when we call in a suspension function, it gets suspended. It means that it has the computation time, it can handle other events, it can execute other code, but the execution will return to that thread a little bit later. So it's non-blocking. The thread is not blocked. So suspending basically means that it is resumable, and it will be available in the proper places if you use Kotlin coroutines. And those places are marked with the suspend modifier. And actually, this is a very important concept of Kotlin coroutines and coroutines design, that you mark the methods that is available to suspend thing with a special modifier. Thus, you provide the information for you and other developers that this function may suspend. That's important. But in the code that we're written here, right, we didn't see any suspend modifier. Where it is hidden? It is hidden here. So this is the definition of a async coroutine builder. And it has a bunch of default parameters, like default dispatcher, the start method, and so on. But the most important one is the block. So this is the code that we're going to execute in our async. And it has a declaration of a suspend function, right? So the suspend modifier is here. OK. So we figured out the interface of deferred, of job. We figured out what suspension means. Let's talk about cancellation, because this is the difference between deferred and future. So in cancellation, what's about cancellation in general? Cancellation should be cooperate. Did anybody use anytime thread stop? Java developers, you used it, but not for a long time, right? Because they got deprecated in Java 1.1. This is because cancellation should be cooperate. You just can't stop some code without that code knowing of a possibility that can be stopped. Because if you do that, you will corrupt your memory, and this is not what we want. And that's why cancellation should be cooperate. And with Java 2, the cancellation is pretty good, because if you just unsubscribe all your subscribers, the chain will stop producing, and that's good. But in particular cases, you may require to access the current subscription, but they are rather complex ones. Cancellation in coroutines is really cool. Why? Because I will explain why, but we need to talk about the structured concurrency that was introduced a couple of months ago. So in order to use the coroutines in your code, you will need to have an access to a corrosion context. So corrosion context is actually a map of some elements that describe the contents, the context that the coroutine is executed in. For example, one of the values in that context is a thread pool where coroutines will be executed on. So in order for your code to execute coroutines, you need your class to implement that coroutine scope interface. So it's a special interface to mark that the code in this class can be executed in coroutines. And here you define the coroutine context. So this coroutine context will be used by default in all your coroutine builders. So async, launch will use it by default. And here we can see the definition of that coroutine context as dispatcher's main. Dispatcher's main is the main context in your application, and it's platform specific. On Android, it's a main thread. On JavaFX, it's UI thread. In some other application, it can be other thread pool. Okay, so what's about cancellation? The trick is that for handling the lifecycle events for Android or for other applications or for presenters or for whatever, you may need to provide a job that will be cancelled automatically when your class is stopped during your lifetime. And you will need just to provide this job to add it to your context with the special plus operator. I will not get deep dive into this, but I will provide some useful links for that. Just remember that this construction allows you to automatically cancel all your coroutines once your class that uses it gets disposed. And this is the main idea. Okay, but in some corner cases, you will need to check if your coroutine gets cancelled. This is really easy, because in every coroutine, you have an access to those properties that I mentioned in the job interface. You remember, is cancelled, is active, and that's it. You just can check it and do something, maybe some additional logging or whatever. Okay, cool. We just compared the Java approach with coroutine approach in aspect of writing the code and understanding the code. Okay, but we, as a great developers, right, we like to write unit tests to be sure that our code runs smoothly and without errors. Let's compare the writing tests approaches. Okay, so for Java, this is the code I wrote to unit test some of my classes. And it's actually pretty easy. So we need to make some setup, like prepare some mock objects. And then what we need to do is just to call our methods, for example, login method, then call subscribe, and then check that everything is parsed correctly. Okay, seems pretty easy. What about coroutines? So in coroutines, you do pretty much the same. The only thing you need to change is that you need to use the run blocking, so to have some context, okay? And then just call await, and then you will have the same object, and you can call pretty much the same asserts for your code. Okay, so tests look pretty much the same. And you can ask me, why bother? If tests are the same, if code just a little bit better, what's the point? So why should I go and just refactor my classes to coroutines if RxJava simply works? And I believe I will convince you right now. Because with coroutines, we can do much better. So not using any deferred things because they are cumbersome. We may do much, much better and cleaner. And we can do that with suspend functions. Let's take a look. What if I told you that we can use our interface, right now it is called suspending API client, and we can get rid of all singles, all deferred, all jobs, and all other things. And our functions can just return plain business objects that we need to work with. So for example, for login, it will be GitHub user. Or for get repository, it will be just plain the list of GitHub repositories. And the only price that we need to pay for that is those suspend modifiers for each function. That's better, right? It's just some modifiers and that's it. They don't restrict us from anything. And that's good. So the implementation will be easy as well. What we need to do in our implementation is just our business logic. If we need to make an HTTP call, just make it and forget about it. And that's great. Our client code will be a little bit complicated compared with the previous approach. What we will need to make, we will need to call our coroutine builders right in the client code. But that's not a big deal. For example, we just need to add the async builder here and async builder there, and that's it. This is the all modification. But the interface became much cleaner. And what's more important, tests became much cleaner. For example, here you can see that we got rid of all await things and other stuff. All we used is that we mentioned this run blocking thing here, and that's it. So our tests right now looks like we don't have any asynchronous code, but we just need to add the run blocking call to our methods, and that's it. So I'm a big fan of that approach. If you need to provide some more complex test case, because the previous test was just for API client implementation, but what if we want to provide a test case for a presenter that uses that API client? This is not complex as well. I'm using a mock library for providing unit tests for Kotlin, and it has a bunch of functions that helps to mock the suspend functions and builders and so on. So all you need is just to call the coEvery function that will mock your suspend function, and that's it. So pretty easy. Okay, so with mock library, you just need to call coEvery, but I believe it's not that popular. In Android world, for example, everybody uses Makita Kotlin, and you may as well. And it's a little bit more complex, so you need to provide given, run blocking, and that's it. Maybe there's a better way, but I didn't pay a lot of time to find out the one, because I'm using mock. Okay, so let's focus on some first takeaways. First of all, there is a debug tooling for capture actual stack traces, and it helps with the stack traces problem. Less objects compared to RxJava created under the hood. That's a plus. And the code is easier to write, and the interfaces and tests became much cleaner. And that's a great achievement from my perspective. Okay, couple of deep dives. What about error handling with Kotlin coroutines? let's figure out. Actually, in production, with the RxJava or with coroutines or with other asynchronous code, we have different errors on different layers. So the network layer, the repository layer, I don't know, presenter layer, view layer, and so on. And the error handling becomes very complex because our domains are complex, our architectures are complex, and that's it. So what to do with Kotlin coroutines? There are several ways. First one is called coroutine exception handler, and second is result classes. And we tried both of those approaches in production. Let's take a look. So coroutine exception handler is a special object shipped with coroutines library, and it basically provides a way to handle some error. So it accepts a block that accepts an error, and then you can write some code to handle that error. So, for example, you have a default error messages. So you're telling your user something went wrong, sorry. But if you know a particular error that happened, for example, internet went down, or the server returns you 403 or whatever, you can provide a user-friendly message with the base of your actual exception. So, for example, HTTP response exception, and you return that something went wrong. Or connection exception, you're saying your user that he needs to check the connection, enables Wi-Fi, and so on. And if not, you just provide some default error message and just display it. So, good. The only thing you need to use that coroutine exception handler is just add it to your context with the same plus operator that we saw before. OK, another approach is using the result classes. So if you have a lot of switches, if you have a lot of errors, the coroutine exception handler can grow in a very big class, and this is not very maintainable. A result approach is a little bit better in that sense. So with result, you do the following. You're just calling some coroutine builder. I'm using with context here. The difference is not important right now. And then you just check if everything is fine. And if it is not, you're returning an error. But if it is, you just call your business logic and return a success result. And that works really great, and it is really easy to provide unit tests for that logic. OK. But what if there is no spoon? Why we use RxJava in the first place? Because this is a huge library, and it has a lot of stars on GitHub, a lot of contributors, a lot of maintenance, a lot of updates every month. So why do we use it? And RxJava is actually great in handling the event streams. OK. And on mobile, for example, where do we have event streams? For example, for user input. Like our users, like monkeys, type in a lot of information in our search fields. And for example, in our application, it can be a search for GitHub repositories. And there are quite a lot there, right? So we need to provide a decent way to search for repositories, rather performant. And we need to write the code for it rather fast. So let's take a look. How do we solve that problem with RxJava? We do the following. We use some public subject, complex objects, but whatever. We use some debounds. We use other operators. We use some code to schedule the operations on a particular thread pools, and so on. What's important here is that in this switch map that translates our search query to a HTTP request, we use our API client to call for search, right? OK. And then when we get the result, we just display it on the screen. OK, what's cool about this approach? What is good? What do you find good in that particular code? It is rather short, right? And it is more or less understandable. So we have a search query, we have a result displaying, Okay, so it's fine, it's maintainable. And what is awesome is that we have a lot of operators to help us. For example, we don't need to perform a network request for each letter that our user types in, right? We don't need that. It doesn't make sense. So we just add a line with an operator from a RxJava library, and the task is solved. Then we don't want to repeat our network calls if the search query is the same. For example, the user typed in a letter and deleted it in the same particular moment. We don't want to repeat the request. So there are a lot of operators that helps us to solve the problem. But what if I told you that coroutines can do the same and even better using channels? Okay, let's take a look how do we solve the same particular problem with channels and Kotlin coroutines. Well, we use the coroutine builder launch. Then we need to use some special object. I'm calling it broadcast here, and use some special function that is called consume each. And then we do pretty much the same, but the business logic is here. So we just search for repositories, and when we have the result, we put it on the screen. Much less code, right? Okay. So let's figure out what's broadcast. Broadcast is an instance of a special class that is called conflated broadcast channel that works with strings in this particular use case. And I'm going to explain what this object, how it works. Okay, then what we need to do, we need to subscribe for text changes for our search field, and then just put the text into that channel with a method that is called offer. And that's it. Okay, what are the questions to that code? What are the hell are channels, right? What is a broadcast channel? And what the hell means that it is conflated? Let's figure out. What are channels? First of all, well, that's not channels. Channels are like blocking queues. So Java developers should know what blocking queue is, right? Channel is like blocking queue, but not really. It's a blocking queue, but it's non-blocking. So with blocking queue, we have basically two methods, put and take, right? And they are blocking. They block the thread. They are called on. With channels, we have send and receive, and the semantics is similar to put and take, but those methods are not blocking, but suspending, right? Like in all other coroutines world. Okay, so we have a couple of methods, send and receive. They are suspend. Send accepts an element, receive returns an element. Good. So what about broadcast channel? So broadcast channel is like subject in RxJava, but again, not really. Subject is in RxJava, it is an observable, but it can behave like observer, right? For broadcast channel, it is a send channel, and it provides a method called open subscription, and consume each actually internally calls that open subscription. And this open subscription returns a receive channel. So semantics a little bit different, but the task that is solved is pretty much the same. Okay, at last, what is a conflated channel? Conflated channel is a basic broadcast channel that we figure out what is, but it's losing the elements. And this is exactly what we need, because if we don't want to repeat the same thing, or we don't want to have the results for previous inputs, we just may forget about the elements that were before. And conflated broadcast channel is our choice. Okay, so we can do the same search, and it will be with the same performance as with RxJava, but the code will be cleaner and easier. But if you still need to integrate with RxJava, you may use a special library that is called Kotlin X Coroutines RxJava, and it is on the GitHub, of course. It provides a bunch of converters and extension functions that can convert from RxJava world to Kotlin coroutines world, and back and forth. So from other side to RxJava too. So for example, there's a Rx completable function, Rx maybe function, and so on. So this is the table. I think you can study it a little bit later. Also, we can convert the job, like Kotlin corroutine, to completable thing, defer to single, and so on. And the channels are convertible as well. Okay, where we want to apply those converters? There are several use cases in our day-to-day life. So, for example, you're using libraries which expose Rx adapters. Half a year ago, there were no Kotlin corroutine adapter for a popular network library for Android that is called Retrofit. And that was a perfect use case for using those converters. But right now, they, of course, has an adapter that provides Kotlin coroutines interface. Or maybe you want to use coroutines in the applications that are based on RxJava. And you may know that RxJava just fulfills all your project. You just start using it in one place, and a week later, RxJava is everywhere. So if you want to introduce coroutines and you need to integrate with some parts of your code that you're using RxJava, this is the converters are your choice. For example, this is the thing that I encountered in a production application, and it was a little bit a sad story, because I had the following complex RxJava chain. So I had some observable, it had a subject, it was zipping with some other subject, and it did several times. There were side effects in each zip function, and so on. And it was really sad because those side effects use event bus, and the original task was to get rid of event bus, because event bus is awful right now. Don't do that. And I spent a whole day just trying to figure out how to step into the problem, and I didn't manage to do so. But then I thought, why I need to use RxJava, why I need to use a complex instrument if I can use a simpler one? And I just went to Kotlin coroutines, and I did the same in 4 hours with coroutines, and it worked amazing. So I encourage you to use Kotlin coroutines because they are really easier and they are good to refactor from RxJava. Okay, my story wouldn't be completed if I didn't tell you anything about the limitations. And the only limitation I know, except for integrating with Java world, is that channels are basically hot streams. So there's no support for cold streams. However, Kotlin coroutines are lazy enough, so there are parameters that you can pass into coroutine builder to use them like cold streams, but they're not fully cold streams. So they're not lazy enough. And there's a suggestion how to implement those cold streams in Kotlin coroutines. This is the link to a discussion on GitHub, and the guys from JetBrains put a lot of thoughts there. So just go and read it. And that's basically it. What I was going to tell you about Kotlin coroutines today or tonight. Okay. So the most useful part of every presentation is links. Okay, so first of all the code you see here you can access on my GitHub. Please star. If you want to use the same mocking library that I used is mockk, and the link is here. Then I'm using an KHTTP library for using HTTP requests, just to know some other tools than Retrofit and basic HTTP clients. And of course, please follow me on Twitter. It's really important. I tweet a lot about technologies, about Kotlin coroutines, about mobile development, about solution architecture. So please follow me. And I write articles about Kotlin, about Android on Medium. So please follow me there as well. That's me, and that's it. Thank you very much. Any questions?
Well, I have a question from the point of view of a .NET developer, which is not very familiar with this stuff you were saying. So there are different patterns in concurrent programming that we know. And for me, there are two major patterns, which are, for example, .NET like async await and Go like Go routings and channels.
Yeah.
And I heard some things from both of these worlds in your presentation, and I couldn't grasp it to full extent because I'm not familiar with all this Java-specific stuff. So I couldn't really get it, whether it is more similar to .NET or JavaScript style, or is it more towards Go routines and channels.
Okay, okay. I'm not a .NET developer, nor Go developer, but from what I read about those topics, Kotlin coroutines uses some concepts from both worlds, and there are differences both with .NET and with Go, but there are similarities, of course. For example, with .NET, the functions that are using the async await semantics, right? They return tasks. Yeah. There are no tasks here. So you may return deferred, right? But it is not idiomatic way. The idiomatic way for Kotlin coroutines are suspend functions. So, and suspend functions just return your objects, okay? And with Go routines, I'm not sure, but what I remember is that the semantics is a little bit different as well, and there are some performance things with Go routines, but I need to check it later, so I will check.
One more question. In .NET world, we have this problem that an async function can continue on the same thread as well as on a different thread.
Yep.
Do you have the same issue in Kotlin, and do you have ways to overcome it? Is it an issue at all in Kotlin?
I'm not sure if it is an issue, because every async thing that you do with coroutines, they are launched on their specific context, and they will be executed right there. So not on other thread, not on other context or other thread pool. But if you want to continue the coroutine on other context, other thread pool, you can always use with context coroutine builder, and it will switch context for you. So there's a way to overcome it. Okay, any more questions? Okay, if there are no, you can reach me on Twitter or on Medium. Yep.
So if someone would start with Kotlin in 2019,
yep.
What technologies would recommend? What framework? So you said more Concur or Mockito Kotlin? What else?
Okay, what do you want to build? Like Android application?
Yes.
For Android application, it's a complex topic because nowadays mobile applications are as complex as server-side ones, like enterprise ones. They have modules, they have dependency injections, and so on. So for example, for dependency injection, you can use Kotlin or Kotlin. Those are new tools, and there's a Dagger. I believe you use Dagger for Java dependency injection, or maybe you use Spring. So Dagger is more like Spring, and Kotlin is a completely new thing that leverages the capabilities of Kotlin. What else? There's a special. It's not like an application container. It's a web server for Kotlin. It is called Ktor, and if you need to bootstrap a web application really fast, you just use it, and that's it. What else? What to use in mobile development? There are frameworks for managing your views, like MVVM, MVP, and other view layer architectures. So for MVVM, Kotlin is a very good companion. So please use MVVM approach, and for MVP, it's not that great. And maybe that's it. I need to have a more specific question to answer. Okay. Anything else?
If we speak about server-side development,
okay.
What would you say about using Kotlin, and what advantages and drawbacks would you find in it, and would you personally recommend it?
Okay, so nowadays we have a situation when server-side is not like in good old times when you have a hardware, have have our operating system installed on that, having an application container like Tomcat or Glasssphere or whatever you use, and then a web application and so on. Well, nowadays we have containers, we have lambdas, and so on. And the question is really different for everything. So, for example, for the good old days approach, Kotlin is really great because you just do the same as you do with Java, but 1.5 times faster. Because code is shorter, it is more expressive, the tests are better, like everything is better. The standard library is better, and that's it. You have coroutines and all other stuff. But for example, for Lambda or for serverless, it's not that great because some time ago I was using a really tiny application, server-side application, and had to implement some logic, but there was a limit for a code amount. So it was like 5 megabytes for instance, for example. And you could use Java, but I wanted to use Kotlin. But I needed to use Kotlin libraries because you just can't run Kotlin everywhere where you use Java because you need a library. You need a standard library of Kotlin, right? And this standard library is rather huge if you compare it with 5 megabytes. It's like 3 or 4, and it was all the size of that was available for me. Okay, so it was like I needed to just write just a little code to fit into that limit. But I believe if you're okay with paying some money for that, Kotlin is great as well. So there are some other issues or runtime issues or whatever. Kotlin is now stable. It is stable for more than 1 year. So it is already released 1.3, and there are a lot of issues with tooling, with compiler, which are solved. So you're good to go with Kotlin on server side. So please use it.
If you compare it, for example, would you go for some Java 10 or whatever this contemporary stuff and Lambo, for example, versus this Kotlin stack?
Okay.
If you compare it, what would you say?
I would use Kotlin. I was against Project Lombok when it was introduced in like 2011 or 10. And I was always thinking that all those code generators are not good because when you generate code, you don't see it like you can't search for it. You can do a lot of stuff that you can with the code that you write. Okay, so I was against Project Lombok for like always. So so please use Kotlin again. Okay, anything else? I have just a small request. Let's do a photo together. Because it's cool. Just a smile.
One thing.
Okay. Yeah, just come.
So you
come close.
want us to come with you, or you?
Yeah, just come here. So I will take a selfie with all of you. Что ты делаешь?
А вот здесь хотел показать нашу GDG Riga. Нету?
Нету?
Нету. Ну окей. Окей.
Окей. Yeah. Ты сфоткаешь?
Ну давай. Окей, я вот фотал. Yes. So on 3. Yes, 1, 2, 3. Hey. Yes.
Okay. Thank you all.
Yes. One thing from my side. So we have Можешь открыть нотпад какой-нибудь?
Да, пожалуйста.
Да. Yeah. So for those of you who don't know, if you want to find similar events like this, go to our website, gdgriga.lv. You'll find the meetup page, and you can register for all the spam. So last year we didn't have a lot of events. We promised to be better this year. Yes, and if you go to any other country, any other town, try to Google GDG in that town, like GDG Vilnius or GDG Tallinn. You'll find a group there, and you can speak and become an international speaker like Vladimir. So let's applause again to Vladimir.
Woohoo!
Hope to see you next time.
Great to see you all here.
Yes, so